Today we'll be working on review of factoring, part 1. I have highlighted the sections that we'll be working on today. Alright, let's begin. Okay, so let's start with number 2. We have x to the power of 3 minus 2x squared plus 9x minus 18. So take a look at this problem real quick and notice the exponents. They're already descending. They're already in descending order. The first one's to the power of 3, the second one's to the power of 2, and so on. Therefore, we don't need to flip anything around. Now, for this polynomial, what method would we want to use? Notice that it starts with x to the power of 3, which means we can't use the box method, we can't use a FOIL method. So for this one, it would be best to use grouping. So what we'll do is figure out what the greatest common factor is of each binomial here. For each of these sections, we want to figure out what the greatest common factor is. So we have x to the third and negative 2x squared. In other words, what is the biggest monomial that we can take out of it? For this one, it would be x to the power of 2. So to take x to the power of 2 out, we need to divide the whole thing by x to the power of 2. What is x to the power of 3 divided by x to the power of 2? Just x. And then negative 2x squared divided by x squared is just negative 2. Now let's move on to the second piece. We have 9x minus 18. What is the greatest common factor between these two monomials? That would be 9. So, if we pull out 9, we need to divide the whole thing by 9 as well. What is 9x divided by 9? Just x. What is negative 18 divided by 9? Negative 2. And the way we can check our work is by making sure that whatever's inside each of the parentheses are equal to each other. Is x minus 2 equal to x minus 2? Yes, it is. Therefore, we did our work correctly so far. So now what we're going to do is take the first part and group them together. We have x squared plus 9 and x minus 2. From here, therefore, this is all we need to do. X squared plus 9 times x minus 2. Okay, so from here, we are going to try number 6 now. And real quick, before we move on, remember, you can distribute everything back and check your answer that way too. Okay, let's move on to the next problem. Number 6. We have 3r squared minus 8r plus 7. So the question asks to factor the polynomial completely. So, what is the method that we would use if it's to the second power? We would use the Xbox method. So let's make our Xbox here. Let me make that a little nicer. So AC would go on the top, B goes on the bottom, and remember the top part is we need to multiply and the bottom should be added together. And let's go ahead and label each part real quick. 3 is our A, 8 is B, 7 is C. Remember, it just goes in descending order. So from here, we need to multiply A times C, which is 3 times 7. 3 times 7 is 21. Our B is 8 or negative 8? It would be negative 8. Remember that the whole chunk counts. The symbol that's in front of the coefficient is also included. So from here, let's make a table. Let's do this in red actually. We need to find the multiples of 21. We have 1 and 21, 3 and 7. Now, let's go and add this up. Before we add it up, let's look at our symbols real quick again. We have negative 8 here, right? So we need to find two numbers that add up to negative 8, and we already found the two numbers that multiply to 21. So, is there any way that we can change this number? Let me do this in another color actually. Is there any way that we can change these numbers to add up to negative 8? Well, let's try it out. 3 and 7? No. 7 minus 3 would be 4, and 3 minus 7 would be negative 4, so that wouldn't work. 1 and 21? There's also no way. So for this case, you would just write that it's unfactorable. Unfactorable. And this is just for now. Later on, we'll learn another method when we have numbers that can't be solved with this Xbox method. So for now, it's just unfactorable. Let's move on to number 8. Okay, number 8. Negative 6q to the power of 3 plus. 1 second. Q plus 28q squared plus 10q. Okay, so from here, take a look at the problem real quick. Our first step would be to make sure that all the exponents are in descending order. 3, 2, and 1. There's an imaginary 1 right there. And figure out what the greatest common factor is from these three terms that we have. So let's see. Let's look at what is the GCF of, let's see, the GCF. Let's just look at negative 6, 28, and 10. What is the biggest number that we could take out of all of these? To do this, you can find the multiples. 1, 2, 3, 6, and so forth. 10 cannot be divided by 3. So we automatically know that 3 is not the biggest one. So let's go ahead with 2. So the GCF for this one is going to be equal to 2. But what about the variables? Is there a common variable among these 3? Yeah, it's q to the power of 1. So our second GCF would also be q. And these two combined give us 2q. So we're going to need to take out 2q. Let's move this over here real quick actually. Let me rewrite this problem one more time. Negative 6q to the power of 3 plus 28q to the power of 2 plus 10q. So we're going to take out 2q. To do this, we need to divide everything by 2q. So we can pull out the 2q and write it in the front. Negative 6 divided by 2 is negative 3. Q to the power of 3 divided by q is q to the power of 2. Now let's move on to the next one. 28 divided by 2 is 14. Q squared divided by q is just q. And then we're left with 10q divided by 2q, which is 5q. And we're also going to go ahead and take out this negative in the front. Let me circle it real quick. We want to get rid of this negative in the front. So if we want to get rid of this negative, we're going to have to change everything inside the parentheses as well. So let's take out the negative, which leaves us with 3q squared. Now we need to flip this one as well. And we need to change positive 5q to negative 5q now. So notice that all the signs changed. Now we can use our Xbox method. Let's make this a little longer. So remember, a times c on the top, b on the bottom. We need to multiply and add. So from here, let's see. What is 8 times c? 3 times negative 5, which is negative 15. Our b is negative 14. Now, I want you to figure out what two numbers multiply to negative 15 but add to 14. Okay, so now let's work on it. 1 and 15. What are those all there? There's 3 and 5, and that's all we can do. And now we have negative 15 here. So we need to figure out how to get a negative 14 from the numbers that we've created. So to have a negative number, as a negative final answer I mean, that means a bigger number has to be negative. So we can go ahead and put negatives on the bigger numbers. Otherwise we would have a positive number. So 1 minus 15 is negative 14. Oh, I forgot to put a negative up here. 3 minus 5 is negative 2. Now which one of these two is equal to negative 14? The top one. So now we're going to create our equation. Remember, we need to include whatever was here in the beginning. So we need to bring down this negative 2q. Let's do this a little bit over here actually. Negative 2q times q minus 15 times q plus 1.